Hello wonderful person, this is Anton, and I'm standing on the surface of a very unusual exoplanet with very unusual star that you see in the sky right there. Today we're going to talk about the shape of the star, why it's shaped like this, and what may have actually created it as well. Welcome to What the Math. So let's actually just start by leaving this particular planet and let's take a look at the actual star, and I'll give you an idea of what we actually are looking at. So this exoplanet is actually a terrestrial planet that is around a star known as OGLE 2005 BLG 390LB. This is an actual exoplanet we've discovered. Might not look like this, but it's definitely out there. And this star is located right there. Now I'm going to actually approach it so you can actually see its unusual shape. Let's go to this object. Let's take a look at it. So this is a red dwarf. We're going to turn a little bit, and what I want to do is accelerate time here just so you can see what's happening to it. So very recently, on October 2016, NASA actually made this really interesting post and called these space pumpkins. And it actually does look like a space pumpkin. If you really look at it from a distance, you'll see that it actually spins and rotates and kind of looks like a bright orange pumpkin looking object. And of course they posted this because it was Halloween, because everyone was carving pumpkins, and it was kind of cool to talk about these objects. But what I wanted to do in this particular video is explain to you how these objects may have been formed and what's actually happening here. So first of all, many of these stars are actually very massive. A lot more massive than our sun, and up to like 4 times bigger than our sun, but they spin a lot faster. And because they're spinning so fast, they're creating this oblong shape. So basically this is formed by the spin. If I were to increase the acceleration here, or I guess time progression, you would see that the spin is essentially causing this to create this oblong shape. And we have many different objects in our solar system that actually do have a similar shape because of this fast rotation. But there's something else that's interesting about these particular stars. And the interesting fact is that they actually emit a lot of X-ray radiation. They're very highly energized because of the spin. Now, it's possible that it's because the spin also creates a much more powerful magnetic field, and magnetic field will then cause the star to actually essentially release tons and tons of energy as it basically creates these various solar flares and various solar effects that we observe in our sun as well. But it's possible that there's also something else going on in there that we don't really know about. But what I wanted to do in this video, I also wanted to actually show you how these stars are possibly made and how they're possibly created, because we know quite a lot about them, but we're not entirely sure how they were made, except for maybe one theory from like 40 years ago. And so let's use Universe Sandbox 2 to try to recreate the situation where these pumpkin shapes are formed. Now, unfortunately, this game does not create a pumpkin shape, even if something is spinning really fast. So even if the star begins to spin ridiculously fast, it will not really turn into a pumpkin. The only way for us to actually create a pumpkin is to go into the user objects here, or regular objects that is, and then to actually add an actual pumpkin, which would of course create a pumpkin. And there you go. It's a super ultra massive pumpkin that I think is going to possibly destroy the star, or at least cause it to collide with itself, because it's more massive than the star I just created. Now, the star I created is called KSW71. I'm going to erase the pumpkin before it destroys it. This is one of the known objects that does have this pumpkin shape, and it's one of the objects that NASA actually has discovered very recently by looking at these region of stars that Kepler telescope was looking at. And they actually discovered at least 18 of these really bright stars that all seem to have a very fast rotation. So I can actually increase the rotation here to about 2 hours per rotation, and this would actually make it really oblong and turn it into a pumpkin shape, but unfortunately it doesn't. Now, how do these stars form? This is actually the interesting question. And so the only hypothesis we have right now is that this may have been actually a dual system before, a dual star system, with both of the stars kind of orbiting around one another quite gently, quite nicely. And here we go. I'm going to actually accelerate the time here so you can see how they start orbiting around one another. And one day, one of these stars, possibly this star, started to basically expand because it was approaching the end of its main sequence life. And as it expanded, and let's just do this very gently, as it expanded, as it increased in radius, it is eventually kind of sort of swallowed up the other star. And, well, maybe there was a supernova, maybe there wasn't, but basically at the end what we got was a very fastly spinning star that became a pumpkin-shaped star because of the spin. Now, obviously, one day the supernova will disappear, and what we'll get is a very unusual formation with a star that spins ridiculously fast. It's oblong in shape, and it also produces quite a lot of X-ray radiation because of its spin. And to be honest, that's actually all we know about these stars. So the supernova is about to disappear because we're actually advancing time in ridiculously fast increments. And there it is, it's disappearing slowly. But basically, yeah, that's all we know about these stars. We know that they're very highly energetic. We know that they produce a lot of X-ray radiation. And we know that they spin really, really fast. And this is how we think they were formed. Other than that, we don't really know much about them. We've discovered about 18 of them so far, and we expect to find maybe about 150 or 160 more in the next few years. But as we discover more and more about them, we might learn their true origin. For now, that's all we think that may have happened here and how these stars were formed. And anyway, so let's actually stop this video here, and if you've enjoyed it, don't forget to subscribe if you still haven't, share this video with your friends, and possibly consider supporting this channel on Patreon, or leave a comment below. Do you know anything else about these stars? How do you think they were formed? What do you think happened here? And why do you think they spin so fast compared to other stars, including, of course, our sun? We're going to place a few more stars here and cause some serious trouble to this particular solar system, because I don't think this is going to be very stable, especially with Betelgeuse right there. I'll see you guys in the next video. Let's find out what happens in this system. I expect a lot of supernova, but maybe not. I'll see you in the next video. Game you later. And as always, bye-bye. And look at that. Apparently I actually created a somewhat stable system inside a supernova. These guys are orbiting just fine around one another, and nothing got destabilized. Well, that's interesting.